Hello guys, let's disassemble Kinect sensor. It is very important to cut it at the same place as I did, because that is sufficient length for our project. We have to disassemble main body of Kinect, and it has hidden screws, exactly 6 screws. There are 4 screws under these covers, and there are 2 screws under the stickers that say Xbox 360 on left and right side. We will use screw tip as shown in this video. After removing screws, Kinect simply falls apart. We are left with front plate and with stand. We can remove fan and other unnecessary parts for now. Now we can remove front plate screws that hold front plate. There are 4 screws. After removing them, we will be faced with microphones that we don't need. Need these 3 lenses, 3 big lenses and 1 small lens. And we will need this plastic part that is pressing them to the front place. Now I am putting them in Ziploc bag for safety purposes, so I don't damage them. Now the problem is a stand, but it is not so easy to remove it. We will first need to disassemble main body of Kinect, almost Kinect. Now there is the plug that we need to wiggle carefully, and first we need to remove 4 screws. Now when removing these ribbon cables, you need to be careful, because these are camera ribbon cables and you can pull them by pulling the paper that stick to them. And remember the orientation of these connectors, where they were put in place. Now we can remove other screws and spacers. Now we can remove Kinect stand. Just don't damage the main connector. This plastic part we don't need, and we can remove it. We will see later on why we don't need it. Now we can shorten these metal sheets of Kinect scanner, and we can make place for tripod nut to be mounted here. We will later on in project see why. Just do as it is in this video. And be careful not to bend these sheets too much. Now I have returned brass part at the place, and I will remove this cable holder because we won't need it. We won't have any use for it later on in this project, so why not? And just be careful around this part. It is a straightforward process. There is no need for explanations. Just remember which connector goes where. For example, this left side, the first connector point is for camera, second is for fan, and third is unused. You need to make wire go around the spacer inside so that it won't be damaged when we put it in the case, when we slide it in the case. Now we will need to connect this to main cable is connected to main board, and there is LED cable that's connected to the outer board. And now we will reassemble everything. So I have successfully modded Xbox Kinect main body, and I have done that multiple times. Now we are setting up 3D printers settings. This is main body, and we will just follow the orientation as I have shown it in this screen recording. This is how I printed it. You can do it however you like. You are not limited to my settings and my configuration, but I have done this successfully this way. Every part, so that it needs as little support as possible, and Slicer does not recognize that I have designed it this way, so we'll need to add support blockers. You can type the same dimensions that I'm typing in and orient it the same way, and everything will print fine. I have printed so far six of them successful this way. Now I am placing the support blocker and entering dimensions. Okay, so now we see that it takes only 4 hours and 10 minutes to be printed. I have added this angle to a tripod nut holder so that we won't need support for it, and it will still be sturdy and strong enough to do its function. Now we have a fan that needs to cool Xbox Kinect, and it is circle, so we won't need any support because it will close on itself later on. And Slicer will auto-generate support for it, for the top part of it. Only place where we need support is on surface. And I have added also angle here where there will be a fan cover, as you can see here, so that we won't need any support there also, and later on we can remove this unnecessary support that Slicer auto-generated with screw, or we can leave it, it depends. I will remove it later on when it's done printing. Now we will see settings. So I am using one vertical shell. Infill is line and it is 10% connected type. I'm using brim because I like to have more surface contact. I don't like craft at all, so I'm not using any of it. I'm using grid and a honeycomb pattern for support because I found it's best suited for my configuration of printer. Now for printing these big parts I'm using PETG that I got really cheap, and this is the configuration. I'm going with the lower temperature like 220 Celsius, and then I am bumping it up to 235 Celsius. Maximum fan speed is 80% because I have strong fans, and retraction is 1 mm with nozzle of 0.8 mm. So I have really big nozzle, very small retraction, and that is how I find my printer works the best. Now we can save this G code. Now we will need back cover. The back cover is as it's shown. We will make the same orientation as before with the main body, and we won't need any support. I will leave brim because I like surface contact. Because we are printing it from one end to other of printer and at angle, at 45 degrees angle. So leveling is not always good, no matter how much you try to make it leveled. We can experiment here with patterns, because if you use crystal clear material it will be seen through, and I am exactly using that material, as I will explain later on. Now we want case to be as light as possible, so 10% infill is good enough, and now it's only a matter of what kind of design do we want. Do we want cubic, honeycomb, rectilinear, line, or so on. I have decided that the best fit for my design is rectilinear, and it takes 1 hour and 30 minutes to be printed. As filament, I am now using PET filament, and I will change settings. PET filament is from recycled bottles, and the settings are shown here. It is printing at 275 Celsius and 80 degrees, almost Celsius degrees, bed temperature. So it's quite hot here. Now I need a couple of bottles for this. I think I need 1.5 bottles for this one of cola, 2-liter cola, or whatever other juice. Now we are going to save it, and we will have another part. We will keep configuration because I am going to print front cover now with the same material, because it's really strong. It is more brittle than PETG, but it is stronger. It is stronger than PETG. Now we are going to orient it the same way, 45 degrees, give or take. And I'm going to use same settings. This is also support-proof design. We don't need any support. And there is my logo. If you are using a see-through material, then you need to add this pause. I'm using clipper. Now I am adding pause that will tell printer to stop, and I'm going to change filament so that the name is in different color than the front, first front layers, so that the name will come to light. It will be better seen. I don't recommend this approach with see-through filaments because it won't look so good. As we will see later in the video when I assemble the 3D Kinect, the letters will need to be filled with white or other color. Now I'm adding pause at 2 parts, and this is like the pattern that will be seen. This vertical and horizontal infill will be seen. And that's it. I am just double checking because I don't like to waste material. I wasted enough on making prototypes of this, so enough is enough. Everything looks fine. That's me showing that it has angle and it does not need support. Now I am showing here that I am using same configurations and that I am using Clipper firmware. And that's the reason why I needed to add custom G code, because Clipper does not recognize M60, 600 command and so on. It recognizes pause command that I had to add to printer configuration. Okay. Okay, so now we have 3D printed our parts and we are going to reassemble it. I have test fitted parts and cleaned oozing and other problems, so now everything is ready to be assembled. Now I have mounted this Kinect body to prototype, to front plate prototype, and I am unscrewing the screws and transplanting it to final front place. I'm using heat gun for the soldering. The regular lighter will not work, it will create crystallization. It needs to be high temperature lighter. Now I am transporting lenses to the new phase. You don't need to be so careful, we will clean the lenses later. The most important thing is to clean them inside. Outside we can clean them later. I'm using drill to drill holes to the right side of the body's frame, Kinect body's frame, and the reason for that is for aligning of camera with faceplate holes. And after test fitting it, I am removing black part and I am sliding the front plate in its place. Now I am inserting the holder of the lenses. Now I'm going to wiggle in Kinect main body. Finally, I managed to put it in, but I had to cut the scene, so no worries. Now this fan cable needs to be from the inside out, so that it won't disturb our process of putting Kinect body in its place, because it's a really tight fit. Now I am screwing the screws in its place. After doing this a couple of times, I would recommend aligning it, then screwing the left side of the body, but not completely. Leave just a little bit of wiggling room. Then we will wiggle from left to right, and we will align camera with lenses and front face. I am now checking if the alignment is correct. When I am satisfied with alignment, I will screw the screws permanently. I have noticed that the hole is way too big for it to hold the main body, so I am adding a washer that will make a contact surface with main body and screw. Front face assembly is done. Now we are mounting a fan. Now the fan cover is pushing outwards, and we will use a heat to melt it or shape it in its place, inwards. It won't touch fan. You'll need USB-B port and separate power connection, standard power connector for this part. First we will unscrew 5 screws that are holding the first PCB in its place. Now we will remove the main connector that has data pins and additional power pins. Now we are adding tripod mounting nut. I'm waiting for heat to transfer to the brass nut, and it needs a little bit of guidance. So I'm using these tweezers for dentists, and heat transfer is really low for them. So I can hold the brass part and push it with soldering iron. I am pushing it straight in, and I am transferring enough heat for it to melt plastic around it. Hello guys, so after everything we have done, this is what we get. Now I had 6 of Kinects and 1 did not work. I'm going to test Kinect application with this sensor, or sensor with this application, and this is how it looks. We have USB-B, we have barrel 12 volt DC adapter. I was surfing on Amazon and I found that this adapter uses 12 volts, 1.08 amps, so 12 volts, 1 amp, 1.5 amp and so on will be fine for our purpose. Now, this is a solution for fan. This grid, metal grid, is from used PCU, from PC. Backside that we can see when we turn our PC on the backside, and I had a couple of broken PCUs laying around and I decided to cut this mesh out. So I'm using only 2 screws and it is very strong. And I found out that I think that it is better solution with this design. Now it is needed, color is needed, we need to add color in order for the letters to be to pop out, to be seen better or seen at all. Now I'm using this stand. I'm going to show the case now for it, and this is the stand. This is from the local store. in Bosnia. It is like 2.5 euros, so it's really cheap, but you get everything with it. And now this Kinect sensor can be used like scanner easily. So we have a 2.5 euros tripod. It can be rotated as this or as this, and we can rotate this arm here, so it is multifunctional tripod, and I think it's good and cheap suit for this scanner. Now tripod nut sometimes has not every tripod nut I used is the same. Some stay in place, some don't. Depends on the grid on outside of the nut. So that is one of the problems that I faced. Now I am using free application, free version of this application. There is also paid version, and my Kinect is registered. Now when you put USB, it will start to the green light will start to glow. And let's go start. And here I am. Hello guys. Now this is everything functions properly. Now this is not the best distance for 3D scanner to scan me, but I have used this scanner with this tripod a couple times and it works good. It scans good. Now we are not limited to this tripod. We can make machine to automatically do this process for us now that we have mounting point and it has a slimmer design. So that's it for this project. See you guys.